So, last time we finished the topic of first order difference equations. So of course, the next thing we're going to cover are higher order difference equations. Right? However, look, still, now we don't need to learn that much new things, because again, we can use what we already learned about first order difference equation, combine it with what we learned about second order differential equations and higher order differential equations, and we're gonna do with higher order difference equations just next. Now, similarly to what we've been doing with differential equations, we're going to start with second order difference equation. Okay, and before we go there, let me review with you one more thing. Look, second order difference equation means that we can write this equation in the form of second differences. What is second difference? Well, we already discussed it, but let's remind you. This is how we denote second difference, and second difference of yt is, by definition, first difference of the first difference. And look, because we know how to calculate first difference, it shouldn't be a big problem for us to calculate the second. Because look, this is equal to first difference of yt plus 1 minus yt. Now, I can apply the difference operator to both of these expressions separately. So we get that this is yt plus 1 minus y delta yt. Okay, now, then we can apply the difference operators to each of these expressions separately. So look, over here, we're going to get yt plus 2 minus yt plus 1, right? We did exactly the same thing, just here for t plus 1. So we needed to add t plus 2. And look, then we subtract, of course, yt plus 2 and plus 1 minus yt. And look what it actually is giving us. Look, we've got yt plus 2 minus 2 yt plus 1 and plus minus, right? Plus yt. Okay, and look, this expression, of course, is an equivalent of this. They mean the same thing, they are identities, right? Everywhere here, I could just write this, right? It's all by definition. Now, however, this form is something that reminds us of the form of difference equation, first order difference equation we're dealing with, and also it should remind us of differential equation, where instead of y, first derivative and second derivative, we've got contemporaries observation with 1 lead and with 2 leads, right? Okay, and this actually brings us to a more general point, a specific point. We of course going to start with second order difference equations with constant coefficients German. Okay, so the equation we are going to deal with is in the form yt plus 2 plus a1 yt plus 1 plus a2 yt equals to c. Okay, so now that we know what are we going to be dealing with, let's start by finding the solution. And again, let's start by particular solution. Okay, and look, just as before, we're going to start with trial solutions. However, look, let's just use what we've learned about differential and difference equations. And what should be our first guess? Well, probably we should start with the easiest. So yt equals to k, then yt plus 1 also equals to k, and yt plus 2 also equals to k, where k is some constant. So the first solution we are looking for is a constant solution, as usual. So what am I doing right now is I'm going to substitute this to our equation instead of yt plus 1, yt plus 2. So we're going to get that this is k plus a1 k plus a2 k equals to c. I can take k out. Out of it, that k is equal to c over a1 plus a2 plus 1. Okay, and at this moment, I should notice right away that a1 plus a2 plus 1 must be different than 0. However, we now have our particular solution. The particular solution, so equilibrium solution, is given by c over a1 plus a2 plus 1, and we need to remember that a1 plus a2 must be different than negative 1. Okay, so we've got our first solution that we're going to be using the most common. However, right away, we notice that if a1 plus a2 are actually equal to negative 1, then our solution is no longer going to work. Okay, so let's see what can we do if the solution, if this solution doesn't work. So, what if a1 plus a2 are equal to negative 1? We know that this solution is not going to work. So we start with a new trial solution, right? So, second simplest function, of course, linear function. Now, however, now we see that yt plus 1 is equal to k t plus 1, and yt plus 2 is equal to k t plus 2. So, now let's substitute those results into our equation. We've got k t plus 2 plus a1 k t plus 1, right? And we've got a 2k t equals to c. Okay, we clearly see that k can be easily taken out. And then we've got t plus 2. And over here we've got t plus 2 plus a1 t plus a1, right? And out of this we've got plus a2t equals to c. Okay, we need to rearrange these expressions slightly. And look, let's notice one thing. We see here clearly that expression, we've got 3 expressions with t, right? So let's collect those together. So look, we are getting the k times a1 plus 2 plus t times 1 plus a1 plus a2. So now let's notice very important thing. A1 plus a2 is equal to -1. So this is equal to -1, which means that this whole thing must be equal to 0, right? -1 plus 1, 0, 0 times t, 0. What do we get out of it? So we get here a case where k times a1 plus 2 equals to c, or k equals to c over a1 plus 2, and we notice that a1 plus 2 must be different than 0. However, we get the solution. Our solution is, of course, what we get if we substitute k over here. So particular solution for this case is c over a1 plus 2, and a1 plus a2 must be equal to -1, and a1 must be different than -2. Okay, so we've got the solution now. However, there is still one more complication. The complication that we see over here. What if a1 plus a2 is equal to -1 and a1 is equal to -2? What do we do in this case? Okay, look. Let me just erase the blackboard. So, look, remember, our equation is yt plus 2 plus a1 yt plus 1 plus a2 plus a2 yt equals to c. And look, we now want to try a case where 2 things are true. First, a1 plus a2 is equal to -1, and a1 is equal to -2. But look, if this is the case, that a1 is equal to -2, then this directly implies that a1 being -2, if I'm going to move this to the other hand side, right? 1. So look, here we are talking about a very specific case, right? If I substitute, we get that this is the case where our equation is y2 plus 1 minus 2yt plus 1 plus yt, right? So this is the case of simple second difference. Okay? So look, here we have a situation where second differences are equal to some constant. As it turns out, this is also a very specific, not commonly used case, but very important to understand its principles. Okay, so what are we going to try to do now? Of course, we need to try a new trial solution. And our experience is telling us that now probably we should start with squares. However, this complicates things a little because now we've got yt plus 1 that is equal to kt plus 1 squared, and yt plus 2 is equal to kt plus 2 squared. Okay, let's now substitute those into our equation. Okay? Just to make things simpler, let's substitute it directly here, right? We know that's equal to c. We already included the information we've got from the assumptions. Let's see what we get. Well, we get that this is k, t plus 2 squared, minus 2 k t plus 1 squared, right? And then we've got plus kt squared equals to c. Okay, right away we see that k can be taken out of the parentheses. And now let's calculate everything out inside. So out of this we get t squared plus 4t plus 4. Then we've got minus 2 minus 2 t squared minus 4t and minus 2, right? And plus t squared equals to c. Okay, and now let's see what is happening. Look, this t, negative t squared, cancels those two t squares. Then we've got 4t, negative 4t, and we have 4 and negative 2, so it just leaves us 2, right? So out of this expression, we get that 2k is equal to c, or that k is equal to c over 2. And look, this is how we obtain the last difference equation. The last possibility for a particular solution, and we get that yp is equal to c over 2 t squared, and a1 equals to negative 2, and a2 equals to 1. And look, at this moment, we've covered all 3 possible cases, right? So, before we move on, let's try some examples on how it works. Okay, so let's just say that our first difference equation, for which we are supposed to find a particular solution, and yes, this equation is, okay, yt plus 2 minus 3yt plus 1 minus 4yt equals to 6. Okay, so look, we clearly see that if I add a1 to a2, well, I'm going to get, this is negative 14, I'm sorry, how was it in the exercise? Yeah, oh, it's plus 4, I'm sorry. Okay, so we see that a1 plus a2 over here are equal to negative 3 plus 4, they are equal to 1, right? So, definitely, we are still dealing with the most simple case. We can apply just the solution directly. And we remember that in this case, yp is given by c over 1 plus a1 plus a2. Right? So, this is 6 divided by 1 plus 1, or 3. And this is the particular solution for this case. Okay, so now let's move to the next case. In the next case, in the next example, we've got yt plus 2, yt plus 2 plus yt plus 1, yt plus 2, yt plus 1 minus 2yt equals to 12. Okay, so now a1 plus a2 is 1 minus 2, this is negative 2, right? So we know that the constant solution will no longer work, we need to move to a linear solution. So we try yp. We try yp c over a1 plus 2, right? So we get that this is, then of course this is 12. We know that a1 is 1, right? 2 plus 2, this gives us 3. So, particular solution is simply 14, right? There's not much more we can do over here. Okay, and finally, let's just say that in our last example, there's not much we could do, right? In the case of the last example, right, we are always dealing with the same equation. So minus yt plus 1 plus yt equals to c. So look, if I change it to 7 or 8, we're going to have that particular integral c over 2t squared is 4t squared. Okay, so look, generally, in 99% of the cases, we will have to deal with the case number 1, so the simplest constant solution. Sometimes we're going to move to the case with linear moving equilibrium. However, this one, let's just know how to do it. We're not going to be using it that much. I hope you can see all the similarities between differential and difference equations. All you need to remember that is under certain circumcision, we need to go further. By further, I mean we need to try more complex function. And look, over here, if you choose the wrong formula, you will get division by 0 anyway. And if you get division by 0, it means try more complex solution. Right? So you go from constant, linear, quadratic. Okay, so this is it about particular solution. Since next video, we're going to start discussing a complementary function. See you in the next video.